I am glad to announce that I have reached the enlightenment. I now have Rust code in my NVim config. This thing is powered by Rust. I am doing AST parsing. I'm piping this to NVim, or rather, I'm requesting it from inside NVim via Lua. And now Rust code is officially a part of my NVim config. And I am extraordinarily happy with it. This feels like an achievement. So the code itself is pretty straightforward. There's like nothing difficult. Like we have a lexer. The thing just takes like string, parses tokens. This thing. The idea is we get just like things we can work with, just standard AST parsing. It's even not error prone like Monclad has a very good article on how to make it error prone, but I didn't have time nor care enough, so we have what we have. We will just not be able to parse the things which do not fit the format, which is perfectly fine for my goal, because it's like one-off request anyways, and if we cannot show one single string, so what? So which we shouldn't be able to show in the first place. Now we have lexer there, we parse the tokens, we push them back, and then we start parsing. So we are at two things which happen first. First we go for like this string and capture the parents. Actually, if I you can try to draw, why not? So if I have, where's my R not? Where's my R not? Here's my R not. Okay, so if I try to so say we have like a string, this was parsed as like literal, say, okay, yeah, this is gonna be like key, right? This is gonna be value, and so this is gonna be parsed separately, right? And then actually, matter of fact, where's my, I forgot I can just type text. So say I have key. And then here it's gonna be like, why not named map of, say, A1, B2, something like this, right? So this, when we parse it, what's gonna happen is, can I get larger? Larger, there we go. So when I parse it, we are going to take this separately. This separately, then this separately. This is going to be opening paren, this is going to be closing paren, and then these are individual tokens. This is also like a literal one token. This is one token, the double dot and space, and this is one token. So first, like this is what lexer does, and then we have AST, which takes like this thing and transfers this into a tree, which we can like reason about, and then eventually into a tree kite, which I guess a bit later, where was it? And so first pass we like go for this, and we don't try to assume anything. We just take, we just convert everything on the outermost level. So this is getting parsed. This is getting parsed first, and then we just assume that this parsed correctly, and like later on I can have an error type, but for now we just like parse this, right? What's it called? Whatever it's called. So we parse this thing. Here we have like a map, like curlies. I call them curlies. I have no idea what the right syntax is. So this is like curlies insides somewhere like this thing. Same for all curlies, and we parse it, and then we just match the type of curly to what things are normally inside of them. So like this here, and then that's it. This is parsed, and then we just go like again, and now we see, oh, we have some literal. This is going to be parsed to literal of type of with content named map. It's going to store this, and this is going to be obviously curlies with whatever the content is inside. This is already like recursively starts being parsed. So then this, we just say that this is a literal, And after that, we have some queries contents. So this is a named map. We parse this as a named map, all of it. Right, and then we have a key. Then we have this is still going to be a token. This is going to be a raw token. I represent them like in intermediate step. I'm not sure if it's the best way, but after like first pass, I start having these things. So this is going to be representing the key. This is going to be the key, or rather the key like this, and this thing it's going to be still as overall, and then I think it was something like token. What was it? Interesting. I think I named it. It doesn't really matter, but like so we have this, that, and then this free named map key, and then we something literal, something in regime, something named map. This is parsed into like a key value pair, and that's it. And so we just go through like the patterns one by one and apply them. I'm not sure if it's the best approach, but that's one that worked. So just wrote something that and after that we have very simple actually pass for printing it. So we put this into the serialized structs for tree kinds, and then we just some simple printing the pretty and just retain root. It actually maybe it's possible to do with default formats, right? Just didn't treat the docs, but maybe the root indent can be just derived from the f here, and this could be done with just the difficulty display, but I have no idea this works. So we just take like we take them out like this, and then we expand it. Same thing here, so we take them out like this, and then there we go, we expand it. I can actually show that that's probably the best to go here. So for example, we have this literal, so we have this string. Is it? Yeah, we have this string, and it's going to become like this representation of lexer. So we have like literal gem. This is literal. This is going to parse the literal. This is going to parse as outer gem. This is going to parse as another literal. This is going to be inner lim, and then this is the value, and this is the closing like left curly, right curly. I mean, yeah, that's just all Lexer does. Lexer is the simplest part. The only semi-difficult is AST parser. So as to take this is again like just repeat, so I can easily see, and then this does like this Lexer and starts making it relational tree like. Anyways, we build a tree, just builds a tree. That's it. So yeah, very simple thing, and it's. I think I have a file. Actually, let's get dot stuff like this, right? So, and then inside we have basically let's just actually probably covering it. There you go. So this thing out, and this is just used from the envim itself. So we take the current line in the logs. Current line, we have tracing format. I don't care for any other logs. I'm using Rust exclusively with tracing this format. That's it. So I think it's like pretty log, whatever. I don't remember it. This is like standard, which is accepted across the board. And then this is one line. So basically, it's some white spaces. Then we have word, literal word in, so white space, word in, white space, and the destination, which I'm also taking because it's not as useful. So I can do like yank, and then I have in my buffer I can destination to where this line is, which is useful in some cases to like quickly go there. And then most importantly, we have content, which is easily parsable. This is this part, and here it's difficult to understand what's going on, difficult to see the structure. I had problems with just wasting time on reading this, so now I can do and see exactly what's going on and debug much quicker. So this is amazing. This is amazing. That's it.